Hello everybody, welcome back. My name's Jace. This channel's about my efforts to build a model N-gauge railway. And if you're new here, this video is about building a control panel. There are two previous videos that you may want to go back and watch and then come back and watch this one. If not, feel free to catch up. For those that are regulars, thank you very much. And after the last video that went out, some of you commented saying LEDs don't like to be back-fed, as in power going backwards towards the LED diode. I've took those comments on board and I've come up with a plan to deal with that, and I will show you that in a moment. And I just want to say thank you to everyone that's liked, commented, subscribed. Last week when I went to the NEC show, railway show, we had about 100 subscribers. Pretty much bang on 100 subscribers, and today we're over 200. So in a week 100 subscribers have joined us, so thank you very much for that. Right, I'm going to get the camera set up and I will show you where I'm at. So this is how far I've got. So let's just go back to the LEDs. So I'm operating DCC system. That's around 15 volts, 2 amps maximum. The LEDs are 12 volt, 20 milliamp. And so I've had to build a resistor board. Well, I haven't had to. I could have put the resistors in line in the cable, but I've done it this way. And so we've now got 12 wires will be connected here from the point motors. They come through this block, which we can take apart, through here to this block, which is soldered to the board, through the resistors. And because we have 2 LEDs on each circuit, then we end up with 24 connections up here. We've got 12 points. So 12 wires coming in through the resistors and then into 24 terminals to feed the LEDs, because a point has 2 LEDs mostly per point. Now the eagle-eyed amongst you will notice that there is no 104.3 cable here. That terminal there is not filled, and that's because that LED is this one here. And if you watched the previous video, you'll know that some of the LEDs, about 4 of them, I am planning on leaving on all the time. They won't be operated by the point motors. So these LEDs, all the green wires basically that are point operated, will come round and into here. And I've deliberately put this contact block facing this way, so the wires go in like this, so that when that is on here, the wires loop round nicely and into the block. If I'd have put it the other way around, the wires would be trying to do this when that is like that, and that wouldn't be very good. I've also spaced it off the board quite a long way, and I've just used some screws and, you know, the earth sleeving that you get for domestic electrics, some of that. I've got loads of it left from the house renovation, so I thought I'd use that as a spacer. And the reason it's spaced off so much is if you can see the switch here, when the top's on, that switch, I don't know if we can get underneath, that switch is going to be underneath that board, and therefore the wiring will come out under the board to here. And that one is for point 102. These boards, this one is going to be loads of diodes on there, because I'm going to end up with 24 cables coming in. Half of them are going to go to the negative bus, half of them are going to go to the positive bus, DCC, which is down here. So there'll be diodes on there to prevent the back feeding to the LEDs. And then they're going to get all soldered together underneath and join onto the DCC bus. This one, as I've just mentioned, we've got about 4 LEDs that are permanently on. So we've got 4 resistors here to a terminal block, and on the back they are all just soldered together, so they're sharing a feed from the DCC bus. They're all gonna go into this terminal block, out to the LEDs, back to this terminal block, diodes on here to a negative bus to here. And I'll do a very similar thing to this on the back of this board, so that all of the diodes, there's a negative bus and a positive bus, and they'll all join in, and then they'll go to here. So they've got to be fitted, but I haven't got any diodes, and I'm probably not going to get them until Wednesday next week. So just to bring you up to speed, the long blocks have arrived, as you can see. We've now got DC power, 12 volts, live, yellow, negative, blue, coming through to here, out of there to the circuit board for the potentiometer for the turntable. I will be running a wire across this way to the switches here for the lighting systems on the layout. That's really all that's going to come out of there now, I think. And then all the lighting circuits will come down through this terminal block to the layout. And then they can share a common negative under the board. DCC power, red and black, in here. And then it splits across 4 terminals, 2 for each. And the reason for that is I'm going to have a lot more stuff to connect to the DCC side than the DC side. So the DCC has got more terminals. I've got to join all the LEDs in, and I'm sure there'll be something else as time goes on. So the idea is that this will be like that, this one will be like that, and that will be like that, and eventually I'll probably put a front on it once I've finished doing everything and happy it all works. I'm going to make this so that it just screws together, and then if I ever want to do major work on it, I can lay it out flat like this, and then just screw it all back together. These blocks I've set slightly higher up because I want to get some kind of cable gland clamp here, because although this is designed to be disconnected and put either side of the board, when it is set up it's going to be there for quite a while, so I want to clamp these cables so that they're not pulling out of these connector blocks. So I'm going to have to come up with something for that. The potentiometer yet to go in, that's it there. And then that just plugs into this circuit board. We've got to put a double pole, double throw switch in here, which again is on order. And so what will happen is DC power comes up to the circuit board, out of the circuit board to the double throw switch, from the switch through this block to the turntable motor. So we can reverse the polarity and make the motor run clockwise or anti-clockwise on the turntable, and the potentiometer will be for the speed control. So this is where I'm at, and I think we've resolved the LED back feeding problem. Got my numbers on here, so if you remember I came up with a wiring number system based on the point number and then the terminal of the point motor. So if we look at these wires, this wire here will be from point 100 and it'll be from terminal 3. In fact, all of these will be from terminal 3. They're all from the frog wire, the frog terminal of the point motor, and then point 101, terminal 3, etc, etc. And so all I've got to do now is, as I'm wiring up the points on the board, is run the wires through, making them sure they're long enough, number them up appropriately for each point motor, and then just match the numbers into here. Simple as that. So while I'm going to use coloured wires under the board, in here I'm happy to use white because I've got numbers, and quite often when I'm working on stuff at work, I'll take a panel apart for something on a machine, and every wire will be a single colour, and they have numbers on, and that's quite common. In fact, I once worked for a very well-known digger manufacturer many years ago. I'm talking back in the 90s, I think it was, and they went from coloured cables in their wiring loom to everything being yellow, and they printed a number on the side of the cable. The only problem was, when that ink became in contact with hydraulic oil, it washed off. As you can imagine, we had a lot of warranty claims and a lot of fault finding, but there we go. So numbers like this, white cables, obviously LED cables are green and black, but I'm going to start wiring up the points now. I think the point switches to these blocks, and then when the diodes arrive, I can just move all of this like that, sort my diodes out, do what I've got to do there, screw them boards on, and then that'll flop back over. So to wire up these switches, I obviously need cable, something to cut with. I've got my wire strippers, I've got a screwdriver for the terminals, a knife just in case, solder, cable ties, and my wiring numbers, and some heat shrink. I think that's all we're going to need. So to begin with, I'm going to do this switch that goes under this board, because that's going to be a bit awkward, and if I put wires here, it's just going to make that harder. So I'm going to do the bottom row, if you like, of switches first. So I'm happy if the board can sort of lean back to that angle to work on it in the future. That's perfect. So, you know, the sides are down, that's there, that's like that, front's off. I can work on this. It doesn't need to have loads of spare cable and come out to there. That'll be fine. So I'm going to prop that up. Too much like that. Pull off some cable. And so I want to be sort of from there to there. Tiny little bit of slack in it. Cut that to length. Just want to say, these pliers, I think I got them years and years ago out of a cheap set from Halfords. And I use them for so much stuff. As a multi-tool, this is my go-to when I'm doing the modelling electrics and stuff. You know, even building wagon kits, putting the tiny little nuts on the bottom, perfect for that. Cutting, it'll cut track. It's just a great go-to thing. There's a little tip. So I'll bare these wires. Well, actually, we need 3 wires all the same. So Cut that. There we go. And I'll just bare all the ends of these now. And getting some wire strippers really does help speed the process up rather than trying to use a knife or some snips. Right, I twist the ends together. Some people say you shouldn't. There you go, here's what it is. And then I'm going to take the switch out and we're going to solder these wires to it. Now I've not tightened these up, these are just finger tight, so it's going to be nice and easy to get out. There we are. So you can see there's two ways you can do this, I find anyway. I don't know if you can see, there's tiny little holes in the prongs of the switch. So you can try and poke your cables through those and then solder, which if the cables go through, I will do, which they do, that's good. The other way is you could tin the cable, tin the terminal on the switch, and do it that way. But if I can actually get a cable through, or wire through, that's my preferred method. It's just more positive. Okay. Feels okay. Switch seems to still operate all right. In fact, what I'll do is I'll get the multimeter and we will test that the switch still works, doing a continuity test. So continuity test with a multimeter. For this, I'm just going to use the little buzzer, so it sends a current through, and if the circuit's good, it'll make the buzzer work. So well, I need 3 hands now, or away go. Or away go. So we will put that in there, and the middle wire is power to the switch, so I'll put that one. Should have done it the other way around really, but it doesn't matter. And then if I hold this wire on there and try and operate the switch that way, we should. Right. It's that way. So we've got a current there, continuity of current through the switch, and then let's check the other way, the other pole. Good. So we know the switch works. We know that we've got connections from our wires to the switch. So all I'm going to do is put some heat shrink over those. Need some slightly bigger stuff. a bit too big, but it will do. And I just want to make sure that there is no chance of these wires shorting out or terminals shorting out at the switch. And it will also help strengthen the connection, gives it a bit more support. And then just do the other two the same. And there we go, one point motor switch. Now the other end of this switch goes into a terminal block. So there's different ways I could wire this up now. One is I could have the points in numerical order across these blocks. So 1 here and 12 over here. The problem with that is, you know, we've got where's point 12? Or point 11. Point 11's here, so that would be going over here. You know, point 6 or point 4 is here, and that would have to go over here, and be a lot of crossing of wires. So I think what I'm going to do is take the neatest route from the switch to the terminal block, and then make sure that the wires from the wiring loom underneath go into the correct hole, so it won't be numerically in order, if that makes sense. But what I will do is, say 3 wires go in here for this point one, this switch that we're doing. I will draw some little lines and separate that across here and write in there, or put a sticker in there that is point number whatever, 102 I think. So that's the plan. So we need to see how this looks now. Put it under that way. And these cables are probably a bit long, to be fair. Better too long than too short. I think they'll be fine. So what I've got to do now is put the numbers on. So it's number, just check, 102. So I need 3 ones, because every wire starts with the number of the point. And well, all points, or anything to do with points, starts with a 1. And then whenever I'm working on the layout, if I find a wire and it starts with a 1, I know it's a point. And then its second digit and third digit tell me which point, you know, and it's like 0.1023 or 0.123, sorry. And then the last number, the last digit of the number tells me what terminal of the point motor it goes to. So I want a 1 on every single one of these. And you've got to decide which way around you're going to read the numbers. I've decided I'm going to read them top to bottom, if that makes sense. So this is laying on its back, and the numbers read this way. One. Now you can get label printers for this and different methods. I've just gone with this cheap method. It takes a bit of time, but it's therapeutic. So now I need a 0. And the problem with these is they all get tangled up, and it takes ages to find the number that you want. So 1 0 now. And then a 2, because it's 0.2, so 102. And the reason I've started my points at 100 is because the big layout in the loft that this is part of, that hopefully I will one day take this up and start building the big layout. The big layout, I think, has got something like 80 odd points. Now, plans change all the time, and I wanted to make sure I had enough for at least 100. So it starts with a 1. Why have I got 2 2? That should be on there. That should be on that one. Okay, and now, so at the minute they're all numbered 102. But obviously now I've got to put the individual terminal number on the end. So we should just go 7, 8, 9. 7, 8 and 9 are the terminals coming out of the point motor. So if we go to 7, we'll put that on this one. Now what will happen when we switch all this on eventually, some of the points might work the wrong way round for the switch, and it'll just be a case of swapping the wires either here at the point motor, it's probably, or yeah, you're not really going to do it at the switch, or you can just turn the switch around in the board, but you've also got to get it to coordinate properly with the LEDs coming on for the right road and that. So there probably will be a bit of faffing about. 7, 8 and 9. So there's an 8 on the middle one. Get that on. And a 9. 9, 9, 9. 8. 4. 6. Where's 9? 7. 9. There we are. With 6 and 9, obviously it could be either way up. So you can get them with a little line that you put to the bottom. So I know that that's a 9, not a 6. Nine. So there's the numbers. I'm going to slide them down the cables a little bit so that they're visible sort of here, because that's where I need to know what wire's what, because I've got to join them in here. So we want 7 there. So we'll poke that through. And we'll just check that this is number, yeah, that's number 9. So we will put number 9 in that terminal. And you can faff about with your numbers as much as you like after. That'll be okay, because when the board's on, it'll probably, we can make it bend under that way, like so. That'll be nice and neat. Now what I could do if I wanted to is put a cable tie around there just to keep those three together, but I think in all honesty on that section I think they're fine. I'm not worried about that. Okay, that's the first one done. 11 more to go. I'm not going to bore you with them all like that, so I will just crack on and I will see you in a bit. Okay everyone, so there's all the switches wired for the points. Like I said, I can bend it over this way to do my work here and it will fit on like that. This switch that went through under the circuit board has yet to go back through the top. I'll bring you a bit closer so you can see. So wires from the points to the blocks, numbered up. So these wires are for point 111. That's terminal 7 on the point motor, terminal 8, terminal 9. And that's kinda how it is. I've also written down there the number of the point, what terminals. So you can see they're not in order, numerical order. I just did it in the neatest sort of way for inside the panel. Okay, well that took probably about 3 hours. Yeah, probably 20 minutes per point. What with the soldering, preparing your cables, the soldering, heat shrink, putting the numbers on and connecting it and putting the switch back in the panel. Yeah, probably 20 minutes per switch. But it's a job done now, and I can move forward with it once I get some diodes and stuff. So thanks very much for watching. I hope you've enjoyed the video. If you have, please give it the thumbs up, and if you haven't subscribed yet, please do, and follow me and see how this control panel comes along.